Hey there, coding comrades. Are you ready to embark on a journey into the world of Python? In this class, we'll be exploring the basics of Python, one of the coolest programming languages around. Whether you're a total newbie or a seasoned pro, this class will help you get started with Python and give you the skills you need to create some seriously awesome projects. So grab your coffee, put on your coding hat, and let's get started.
Yeah. So I'm going to create a folder on my desktop. Okay. So it is better to keep everything related to a class or related to a batch. For example, whenever I start a batch, so I create a folder for that batch, and in that folder I keep all the class files so that I can access them anytime, and if someone wants, I can share with them at once. Okay. So I'll be creating a folder. To create a folder, just click on new and go and click on folder. So when you click on folder, one folder called untitled folder will be created. So I have to rename this. So to rename this, you can see this square box. You have to select it and then go and click on rename. So I use a kind of format for renaming the folder underscore big. Okay. So we have this folder created. Now in this folder, we are going to create the Python file. So to create the Python file, we are again going to click on new, and then we have this Python 3. So we'll click on this Python 3, and then this Jupyter notebook is open. Okay. This Jupyter notebook, this is basically, it is, you can say, ID. You can use any ID. Python, your code should not be dependent on ID. Actually, it is not. Okay, the code which you are writing in Jupyter Notebook, same code you can run in PyCharm and the other editors also without making any changes. The only difference why we are using Jupyter Notebook is because when you are going to do the data analysis, or when you are going to create the model, so what you need, it's going to be a big project, starting from data collection to model creation and model deployment. In the middle, you will be doing the data cleaning, then you'll be doing the data processing, feature engineering, these all things. So whenever, let's say, if you write a code in a separate file for importing the code, then you have to bring that file which you have imported in the another file to another Python file where you have to clean that data. So that will become quite a cumbersome process. Okay, so what we are going to do to avoid that, related to one project, we can write the code in a single Jupyter notebook, and also whatever visualization and the output you are going to get, you're not going to get in a different window. You are going to get it into the Jupyter notebook just below this cells. This is called the cell, and this whole Jupyter notebook is one session. So until and unless this session is active, whatever code you are going to write, it will be accessible throughout the notebook. Okay. So Python maintains a global directory, and in that global directory, all the names which you have defined into this, it will be available for you to use. So it is better to use the Jupyter notebook. Okay. You can, this is called one cell, as I said. So if you want to add this cell, so basically there are two mode of operation on the Jupyter notebook. This is called, so this green color line you can see, right? When you can see this green color line, this is called the edit mode. And when you press escape button, you will get into the command mode. Using command mode, you can do the cell related operation like adding the cell or deleting these cells. Okay. You want to add the cells above or below, it depends, so how you want to do these operations. And then if you want to run the cell also, you can execute it, and then you will be getting the output. Okay. So these are a few basic things I think you guys have already discussed. Now I'm going to rename this Jupyter notebook. So I'll just click on this untitled on the top, you can see here. And then I'll be giving the name to this file as class_01_ Python introduction. It is better not to keep the spaces in the names of the file, which you will understand later why we are doing that. And you keep underscore, even don't keep hyphen. Okay. So use underscore, or don't do anything like without underscore. You can write class 01 Python introduction. The first letter of each word should be capitalized, so that is also fine. Or you can use underscore to separate the words. Okay, fine. So next, what we are going to do is we are going to discuss about the Python introduction today. So what we will do here is, so the first class topic we are going to discuss is this one. So today in the introduction class, we are going to discuss these topics. Okay, I'm not going to start with any programming or anything like that today. I'll be discussing about these basic things. I understand there are a lot of people coming from programming background, and probably they might know a lot of things here. So my initial 2 to 3 classes are based on this. We discuss on the memory management part on the Python, why we are using Python, why we are learning Python, what is the use cases of Python. So we will learn about all these things so that you have a clear picture that why, like even if you're coming from Java background, so you should be clear, right, that why we are not using Java, why we are using Python, right? And believe me, you learn a lot of new things because Python, the concepts in Python are, bit different compared to the other programming languages. So our main goal is to, like if you learn Python in these classes, so next time, even for non-programmers, next time if you have to learn some other programming language, it will not be a difficult task for you. You don't have to join probably. You can pick a book and then you can start learning the programming language from there. Okay. So let's start with this discussion. First thing I'll discuss, I'll let you know guys one thing. See, I have a very bad habit of asking the questions. Okay. And I want you guys to respond. This class should not be, I understand it's morning and, we woke up you guys and you're sitting and in your bed, and then probably you are taking these classes. So it is going to be a bit difficult, but please keep these sessions interactive. If you just come here and listen the classes, and if you leave the class, then it is not going to help. Whatever questions you have, whatever doubts you have, you can ask, but we will follow a format. As you can see, there are around more than 50 students. So whatever question you have, one thing you can do is you can write the question in the chat box. Okay. First thing. Second thing, if you have the urgency to ask, just raise your hand first. I will be getting back to you. So what I do, first I complete a topic and then come back, and then those who have raised the hand, I'll be talking to them. I'll be asking the questions from them. Okay. And it's like, if you hold on, probably you will find that the question you have might have, like, we are going to discuss in the upcoming few minutes or something. Okay. So it is better to, what happens, like it gets interrupted in the middle. Okay. So I would request you guys that if you have any question, please raise your hand and I'll be getting back to you. Okay. So that system will follow. And if you have, if your questions are answered, then fine. Otherwise, you can write it into the chat box in case if you feel that you will forget. You'll, if you'll not ask immediately, you'll forget it. So just write it into the chat box or write some keyword into the notebook. Sit with a pen and paper and then write some keywords into notebook, and then you can ask the questions related to that. Okay. As I said, today's class will not be much programming. I want you guys to listen to the class and understand the concepts. Okay. Compiler, interpreter, these all things. So we will be understanding this thing. So let's start our session. First, we are going to start with the discussion on the operating system and programming language. So can anyone tell me why we use operating system? Why we need operating system? Yes, please.
Hello. Am I audible?
Yes, you're audible. See?
Yeah. So, yeah, operating system is just like a brain of the machine that we are working on. It helps us manage all of the applications, softwares that are sitting on the machine.
Mm-hmm.
yeah, it helps us manage memory optimization, all of the processes that are running on the machine.
Correct. Okay, good. Anyone else? Anyone else would like to share something?
I would like to add here, operating system basically manages the input and output operations. Also, the virtual memory thing it manages. It also helps in error detection and handling. So these are few points I would like to add.
Okay.
Hi, good morning. Another point to the previous answer would be the user interface. OS provides the user interface. And apart from the logical capabilities, it gives us and hardware management, there is a user interface that could be utilized for doing.
So manages the other software. It is basically the provides the user interface, you are saying, right? Right.
Yes, user interface.
And then it manages the input output devices and something that to connect hardware with software bit. Okay, from an user based interface, correct? Okay. So we are getting a lot of input. So basically, see, we are not going to discuss about the details about the operating system, and obviously this is not the class related to operating system. But like most of you guys are joining through some device, right? Either mobile or computer. So on mobiles, you have the Android operating system or iOS operating system. On system, you have the Mac operating system or the Windows operating system or Linux operating system. So why we need this operating system? First thing, as we have discussed, this operating system is required to manage the different applications which are running on your device. Okay. It manages the computer, software, and hardware resources. Few people have said that input, output devices, network devices, storage devices. So basically, what we can say that operating system, we need an operating system to connect the user to the hardware, set of hardwares, right? So if you will just look at this. So what we have on the top is we have a user who wants to interact with the, let's say this is the user, and this user wants to interact with your computer. Let's say this is the set of hardware you have. Okay. You have the hardware and this is the user, correct? He wants to interact with this set of hardware. You don't have any operating system, correct? Hardware means to say, I'm talking about the RAMs, don't think about the machines and all of it. So obviously, like, you can operate the machine. Again, there should be some mechanism or mechanics behind that. But let's say when I'm talking about the hardware, so it is computer hardware. You have the ROM, you have the motherboard, you have RAM, hard disk, every set of hardware you have. So will this user will be directly able to give the instruction to this set of hardwares? If you just have the set of hardware, you don't have any software, any operating system is not installed on this. So can you directly interact with it? No.
No.
So for the interaction, you need let's say like what you want to do. Let's say you want to join to a meeting. So you need one application, right? Let's say you need one Zoom application, correct? So you will be taking this Zoom application, and this Zoom application, using this Zoom application, you'll be joining a meeting, correct? Let's say if you want to maintain some data of the sales of the stores, right? So you need the Excel, correct? Let's say if you want to write a note, you need the notepad, correct? You want to calculate something, you need a calculator. These all are what? These all are the applications, correct? So basically to interact with this, you need the application, okay? Now, can these applications directly run on hardware? So let's say if you have 10 applications running, how this hardware system will decide that which applications to run first and which application to run later? How this hardware, so there is no brain in this, right? This is just a set of hardwares. So that decision making into this set of hardwares comes with the operating system. So when you'll be having operating system on top of these set of hardwares, then this operating system will decide for you that which application to run and when. And the second thing, it will decide that the resource allocation, the very important part. There are a lot of tasks that operating system does. I'm not getting into the details of it, like virtualization and all. Okay. But right now, since we are going to develop the Python applications, we are going to write the Python code. So we are discussing about the interface and the the communication between the application and the set of hardware. So basically, if you have 10 applications, this operating system will decide that which application to run and when. Let's say you have input and output devices, that when I'm drawing something here, so it is getting drawn on this whiteboard, right? Why it is not getting drawn in the Jupyter notebook? Or if I'm typing something here, it is getting typed over here, right? So my keyboard is an input device. I'm giving the input to the hardware. So let's say if you'll not be having this operating system, then you will not decide that which application, like where this input and output should go to which application, right? Hardware will, what it will do, so whatever application is open, it will start writing over there, right? So to manage the resources, to manage the applications, we need the operating system, and it's very important. Okay. Going forward in the memory management, we also know one thing, that operating system is also software, and it is the first application which gets loaded into the RAM. When you start your computer, operating system is the very first software, the very first application which gets loaded into the RAM. Because this operating system is only going to manage the other applications. Clear, everyone? Any question till here?
No.
Okay.
It's clear.
So what we have discussed, that operating system is used to manage the resource, right? See, you can say, I'll not say that other things are wrong, but I'm just writing the things which I need, right? Used to manage the resources. First point. And the second point is that operating system is the first application into the RAM, right? Why I'm saying that? Because remember, you have two types of memory, right? One is primary memory and one is secondary memory, or one is permanent storage, one is temporary storage. RAM is a temporary storage, and your hard disk or SSD which you buy in your system, that is the permanent storage. Permanent storage is used to store the data, whereas the temporary storage RAM is used to run the applications, right? So whenever you run the, let's say for example, I have loaded some data, okay, into this file. So when the application is running, when my code is running, that data and that code will be loaded into the RAM, though it is available into your hard disk or into your hard drive, but it will be loaded into the RAM while running the application. And your CPU will be directly, CPU is the processor which processes the data and the code, right? So it will be directly interacting with the RAM, and then it will fetch the instructions and the code and the data from there. Why? Because RAM is faster. If it has to fetch the data from the hard disk, then it will, like, processing time will be huge, and then you have to wait probably for days and weeks to do one operation. Okay, so RAM is faster, so, and your CPU, and it is fast. Since it is faster, so it is quite costly. Okay, so that's the reason you can purchase 1 TB of hard disk, but you can, in the same amount, you cannot purchase the even 200 GB of RAM also. Okay, and if it is not, like it is not there, it is there used into the supercomputers and all, but basically RAM is very faster. Okay, and it is very costly, so it is just used for the temporary storage and to run the applications at runtime. When your application is running, so your CPU is going to interact with the RAM. So OS is going, or any application when you run, when I have opened this Google Chrome, when I have opened this Jupyter Notebook, when I have opened this Zoom, everything is loaded into the RAM. And to run that application, some minimal amount of memory is allocated, and that is done by the OS. So resource allocation or managing the resources means what? Managing the resources means what all resources? When you talk about resources, what is resource? No one asked me this question. So resource is basically memory. Okay, RAM is one type of resource. Okay, ROM, hard disk, is another type of resource. IO devices is another type of resource, right? Input output devices, for example, mouse, keyboard, monitor, screen. Then you have networking devices, right? Networking components. So these are the different resources we have, and these resources has to be allocated for the different applications you are running. Okay, that's why we say that operating system is used to manage the resources. Okay. Fine. So the next question is, why do we need the programming language then? Why do we need programming language? Anyone?
It's like a communication language between.
Because the computer only understands 0 and 1. So to convert it to that, we need a programming language, right?
Okay.
Basically,
0 and 1, that is that you are talking about the hardware. So hardware understands basically the electronic components. Through the electronic components, signals are running. So those signals are considered as zeros and ones, right? So that is a different thing. Means programming language. So someone said about some communication or something. What is that?
Sir,
Yes.
yes, sir.
Yes.
Sir, from my point of view, programming language is used to create applications so that we can make our task easy. Performing of task makes easy.
Yes. Great. Anyone else? So we need the programming language to develop the applications, right? Anyone else?
It's a set of common instructions or a common way of communication, which will help us to, which will help us to create what we need, and it becomes a common language between the developer, or say the person who wants to write the coding, and the computer to understand.
Exactly. So just now we saw this image, right? We have seen this whiteboard where we have seen that there are two ends. One is the user end and one is the hardware end, correct? So if user wants to do some task, you need the application, correct? Right? You need one application. For example, for calculating the data or calculating your monthly expenses, right? You need a calculator application. If you want to make a note, you need the notepad application or some application where you can keep the note, right? You want to schedule the calendars, you need the calendar application. You need to browse something, you need the browser like Google Chrome and Safari, right? So these all are the different applications we need, right, to perform our task, right? So these applications are what? So you interact with these applications, and then when you interact with it, those all are basically instructions are getting passed to the hardware, and then hardware executes them. So application is a very top level of use. Okay. So in applications, let's say if you talk about the Excel or Doc, so backend some code is running, and you use the UI to interact with that applications to give the instructions, and then those what that code is doing, that it is converting those instructions into the code, like whatever you are writing. Let's say Notepad, if you're writing something, so the code, what it is doing, whatever you are writing, it is first converted. It is understanding that what you are trying to do, and then it will convert it into the instruction which your system can understand, and then sends it to the system which can be executed. So backend some code is running. That is very important. It means there is concept of code. You need a language to interact with something. For example, it is not mandated to have an UI to do some task, right? We can write a code in Jupyter Notebook using Python, which can take two numbers from the user and add them. Calculator does what? It takes two numbers and it adds them, right? You will use 10 plus 20, so it will give you 30, correct? This same task you can perform even into this Python code also. So using Python code, I can write a is equal to int input, enter first number. Very simple use case of it. To execute it, I have 10 and 20. So we are getting 30, right? So what I have done, this same thing, you need the calculator. Right now, if you will If you will apply the UI part, then this will become an application. Correct? And in the backend, this code is running, where you have to give 2 inputs and then it will be adding them. And you can design also the kind of calculator which keep on taking the number and then it will finally add, right? So basically what you did, you written a code, correct? So what you did, you wanted to take 2 numbers from the user, so you written a code for that, okay? And then you are printing them. So this is the instruction, basically 3 instructions you have given to the system, and then it is giving you the result. So to give these instructions, you need, like what you are doing, you are interacting with the computer, you are asking your system to take the input from the user. First time, second time also the same thing, and third, in the third instruction, you are trying to add them. So this instruction is being passed to the system. So these instructions are written in a particular language. So if you want to communicate with someone, you need a language, right? Until and unless you are having a language, the communication can never happen, correct? If you start writing something gibberish over here, it will not respond to it. Correct? So I can write anything, but it will not respond to it. It will give you the error. Correct? So basically what you need a language to interact. So there are 2 ends into this image, which we can see here. We have hardware and users. If they want to interact, they need a language. Okay. And using the language, you can develop the applications. Okay. So applications are used for the interaction between the user and the hardware, correct? So application is important. Eventually task is to develop some application to do whatever task you want to do. Whatever, let's say if you want to add the number, you want to join a meeting, you want to browse something, you want to save the contact, you want to send the message, you want, whatever task you want to do, for every task you need one application, and to develop that application, we need the programming language, okay? Clear everyone? Any question? Now, so what is the programming language? In the programming language, what do we need to do? So every programming language is having a set of some predefined words and set of some predefined rules. Okay. So these predefined words are called the keywords or reserved words, and set of predefined rules are called the syntaxes. The whole any programming language revolves around these 2 things: keywords and syntax. Any programming language you want to learn. See, logic development is a different thing, okay? Logic development comes by time. But if you want to learn any programming language, if you know these 2 things in any programming language, probably you know most of the things into that. Syntaxes are very important. Rules. So let's say what is the rule? When I'm adding these 2 numbers, when I'm using this print function, I'm putting this parenthesis on both the ends, right, of this expression. This is a rule. If you will miss one of them, it will give you the syntax error. Okay. So syntaxes are very important. Keywords. So every language has a set of predefined words using which you can perform some task. If you want to iterate something, then you have some keywords. You should have some keywords. You want to repeat a task. You want to check a condition. You want to define a function. For all these things, you need to have some predefined keywords that are defined in the keyword section of that programming language. Okay, so keywords and syntaxes are very important. In Python also, our main focus into these classes will be to learn about these keywords and syntaxes, and the logic development part will come later. As like for logic development, so logic is also an important part, I'll say, in a programming language. You should have this idea. So that will come by practice. The more you will practice, you will become strong in logic. Okay. So those who are coming from programming background, they are fine, so they can manage it. But those who are coming from non-programming background, so along with these 2 things, remember, whenever you are practicing, remember whether you are practicing keyword, syntax, or logic. So you should give the equal focus on all these things. Don't just run behind, let's say, define a function. So define a function is just, you will use some keywords, you use some syntax, that part is done. But inside the function, what logic you are writing, that is more important. Okay, so probably I would say that give 50% importance to the logic, rest 50% will come under this. Okay. Anyway, so I hope this part is clear. Any question, guys?
Clear.
Clear.
Okay. So now we have discussed about this part.
Let's quickly discuss about the types of programming languages.
Discuss about the different types of programming languages. There are many, like, see, there are different types of segregation you can do on the programming languages. There are compiled languages, there are interpreted languages, there are high-level languages, low-level languages, there are generation-based languages. There are languages based on the programming paradigm which we follow to solve our problems. So as of now, just based on the use cases, like which programming languages we are going to use, based on the level we are going to classify these programming languages, and we'll try to understand that why we are learning Python from this discussion. Okay? So the first type of programming language based on the level is low-level programming language. Okay. The second type of programming language we are having is the high-level programming language. Okay. In the low-level programming language, we have different types of language. For example, machine language. It is not machine learning. Okay, machine learning is a different thing. Machine language. This is also called the binary language. Why we say binary language? Because binary means two. So this language uses only two keys or keywords or whatever you can say, two letters, 0 and 1. All the code can be written using 0 and 1. 0 means there is no signal, 1 means there is a signal. And eventually, this is what happening. If I'm writing something when I've written 1, so my operating system, my set of hardware, all the software working together and converting this 1 in terms of 0 and 1, because the electronic components you have, right? Let's say if I'll give you a CPU, if I'll give you a RAM, I'll give you a motherboard. I'll not give you any operating system. I'll not give you any software. Okay. So can you run any code over there? Yes, you can. You can do that. What you need to pass? You need to pass the binary signals. You need to pass the signals to that. Correct? You can do that. You take all the set of electronic components and then connect the way they has to be connected, and then pass the signals to them. It will respond. Okay. So basically your computer, so whatever you are seeing here, whatever you are writing at the very top level, very high level. You are communicating with this in something which you can understand, but your computer is so intelligent that it is converting your language into its own language which it can understand. Computer can understand only the binary language. Remember, computers or your system can understand only binary language, that is the language of 0 and 1. Apart from this, it will not understand anything. And eventually, it is converting everything into the terms of 0 and 1. Okay. And the second language, we have the assembly language. Correct. So these assembly language are another, like, extension of it, is the second generation of language. And the problem into this assembly language is basically like these two languages, why we have kept into the low level language, because you need to understand the basic structure of your computer on which you are going to code. Okay. And in the assembly language, you have to remember the mnemonics. You have very limited set of mnemonics to perform the task, and very limited set of operations you can perform here. Okay. To develop the application in, like, it's not like you cannot develop the application like Facebook and Google and all these big applications in these languages. You can do that, but there are a lot of parameters based on which we decide that which programming language to select. Okay, we'll look at those parameters in some time, but as of now, these all are the two types of, there are many other programming languages also. So we'll not be getting into that. We don't need that. We are mainly focused on the high level programming languages. Okay. So in the high level programming languages, we have C, we have C++, we have C#, we have Java, Python, okay, JavaScript. There are different types of programming language, high level programming language. There are different high level programming languages we have, right? There is no ending list of this, around more than 200 or 300 programming languages we have, right? So now in this, first of all, the first question is, we are learning Python. It means it is a high level programming language. Why we are learning high level programming language, or why we have selected Python? The very good question is why we have selected Python.
Like say it's a human friendly kind of language.
Yes, it is user friendly. Yes, Ashank, do you have any question?
Can you give me some examples for assembly language and machine language like C, C++?
No, C, C++ is, it's a language, right? Machine language is also a language. It is a low level language.
Okay, so do we have like a programming language for that as well, or that itself is the programming language?
You can get here machine language for adding two numbers. See, this is the code you have, this one.
Okay. Cool, thank you.
Okay. Similarly, you can get for the assembly language also. These all are the actually assembly instructions, not this one. Somewhere you see these ones, instructions. Okay.
Okay, cool. Thank you so much.
Clear, guys? Any question? Okay. So now you understand. So probably with this image, you understand why we don't code into the machine language, right? Clear? So if I have to add two numbers, let's see one example. We'll try to understand, we'll try to do all these things. You don't have to do anything, just understand what we are doing. I'm going to take two numbers, okay? And I need to add them. So I'll be taking A is equal to 10, B is equal to 20, C is equal to A plus B, and print C. When I'll execute this code, I'm getting the output. This is the Python code, which is a high-level programming language. I've just written 4 lines of code. Probably I could have reduced it also by just doing this. A comma B is equal to 10 comma 20. Okay, and I'm getting the result. Okay, so in 3 lines we have written the code, and you'll see that this is a kind of code which you can understand. Anyone in this class who cannot understand this code? A is equal to 10, B is equal to 20, C is equal to A plus B, print C. I think everyone is able to understand. Basically, it is a mathematical operation. It's just like, we have done some mathematics in our childhood. It is similar like that, right? And we can easily understand it. We have taken 2 variables, we are assigning 2 values to those 2 variables, adding them, assigning to the third, and printing the third. Simple, right? Now, if the same code, let's say you have to write it to the machine language, you have to give the binary instructions to the computer. There are different ways. I'm not saying that whatever I'm going to do now is the way to get the machine language, but let's see how it will look like, okay? So actually there is a concept of ASCII table and Unicode table. I want you guys to read about it, okay? I want you guys to read about these two things, ASCII table and Unicode table, what it is. So ASCII table is basically whatever keys you have, right, on your keyboard. It is a set of around 128 characters, basically, I would say. 128 characters, and all these characters you will find on in your computer. Okay. Whether it is capital A to capital Z, whether it is 0 to 9, whether it is small a to Z, less than, greater than sign, arrow sign, up arrow, down arrow, whatever, 0, 9, anything. Okay, all these keys you have here, and then you have a corresponding decimal number over here, right? So actually, see, this computers, these hardwares can understand the number. They from decimal number to binary conversion is very easy. Okay, if you will just try to convert this A, let's say when you are writing A, so internally, what it does when you have written capital A. So internally, it will check that what is the corresponding code point. Code point is this decimal value for this capital A. For capital A, it is 65, right? So it will check what is the code point. So it will see that it is 65. Then what your system will do, it is designed in that way that it will convert this 65 into binary. Okay. And then those binary signals will be transferred to the, yes, Ashank? Any question?
No, nothing.
Okay. So these binary signals, these zeros and ones will be transferred to your hardware system, and then it will start executing them. So this you don't have to do it, but let's understand that if I have to convert this A to binary, let's say I have the code A equal to 10. Okay, I have to convert this A equal to 10 to the binary. What I will be doing, I will take A. I know that in this ASCII table, A is mapped to 97. You can get it here. A is 97, right? You can get this decimal number. Don't look at this hex number. You just look at this decimal number. Okay? 97 is the decimal number. Now I have to convert this 97 to the binary. Basically, converting 97 to the binary is what? Getting the binary equivalent of A. So to convert into the binary, 97 binary means 2, so you have to divide it by 2. And then you have to write the quotient here. It is going to be around 48 and remainder is 1. Then this is 48 divided by 2. This will become 24. Then this one will become 24. You keep on dividing it by 2 until and unless you get the 0 over here. Okay, in the this is what, this is the number, and this is the divisor with which you are dividing it. Okay, this is the quotient, and this is the remainder. This will be 48 divided by 2. This will become 24. Keep on dividing this until and unless in the quotient you'll get 0. So this is going to be 0. There is no remainder when you divide it by 2. And then divide 24 by 2. This will become 12, and this will be 0. Divide again this by this 12 by 2, and this will become 0.6, right? Divide 0.6 by 2. This will become 0.3. 0.3 by 2. This will become 1, and this one will also become 1. And then divide this 0.1 by 2. This one will become 0 now. Okay, and this one will be 1. So this is basically the binary equivalent of A. You don't have to do that. Just try to understand what we did. Just to write A, we did all these operations. So I can now, let's say if you want to write A equal to 10, then you will be writing 11, 00, 001. This is A, representation of A into the binary. There are, thanks to Python, we don't have to do for equal to and 10. We have the function called bin, and then we can pass the characters that will, opt. ORD. ORD gives you the corresponding code point for a character, and there is a bin function which can convert this 61 or these code points to the binary. So this is equivalent to equal to. This is equal to, I have written. Then 10 is 1010. Okay, clear? So now just to write A equal to 10, you have done all these efforts. Let's say, what if, like, just think about, you don't have Python. We have coded into these languages back in 1920s, 30s, 40s. We have coded into these languages. So think about the pain that our ancestor has borne. So this kind of coding they have done in the beginning. Now you tell me that, is it possible to develop the kind of applications like we are using today, Facebook, Google, and all these different types of application, complex applications? Is it possible to develop using these machine level languages?
Absolutely not.
No, you cannot do that, right? In case if you develop it, it will, whole of your life, since your birth, you have to invest into it, and then probably it will not be developed. And even in case if it is developed, some application you develop it, Managing will be very difficult. Now you tell me which part of this code represents, say, which part of this code represents equal to, and which part of this code represents 10. Now just think of Facebook application written into the machine language or binary language, and you have streams of ones and zeros. Like, you know, it's going to be the sea of 1 and 0, where you can get into, but you cannot come out of it. Okay. So there was a question from someone. Ragul, do you have any question?
Yeah, yes, Sheikh. So you converted the binary, or you printed the binary of 61, but in that we could see 0B.
Yeah. Yes.
And if it's, since if it needs to be binary, it should be all ones and zeros, right?
Yeah, all ones and zeros. Actually, this 0B is the representation in Python. You remove this 0B. Okay. How Python will understand whether it is binary or it is 1,11,101.
Okay, understood.
Okay.
Yeah, thanks.
Clear, everyone? So now you guys have understood that why we don't select the low-level programming languages, right? Clear, everyone?
Yes.
Okay.
Yes, clear. Yeah.
Okay. Now next we have high-level programming languages. So in this high-level programming language, one more question we have, that we have selected Python. Why not the other programming language? Why not C? Why not C++? Why not C#? Why not Java? Why not JavaScript? Why not Perl? Why not PHP? Why not the other language? Why only Python? Why we are learning Python only to do the data science? To learn the data science? There are a number of reasons. So now we will discuss about the points to consider as programming language. Whenever you are going to select a programming language for doing any task, you should focus on these points. Number one, language should be simple, easy to understand, and expressive language. Yeah. You can select low-level programming language, right? You can code in that. There is no problem. You can code in that. But is it easy? Is it simple to understand? Is it easy to understand? And is it expressive? Is it telling you that what is A, what is equal to what is 10? No, it is not expressive. Yes, you can select C++, C#, Java, probably you can get into that. But let's compare these languages. Let's do one thing. I'm going to take some sample code which can add two number in C, in Java, and in Python. I'm not teaching you Java, I'm not teaching you C or any other languages. I'm just taking the examples to make you understand and create the comparison. Okay. Just give me 2 minutes. Java code to add. Okay. And same thing, sample code to add two numbers in C also you can take. And sample code to add two numbers in Python. Okay. One very simple example. There are a lot of code. Can I have a clarity on this? Yes, Arif? What issue you are facing? Why do the zeros turn red in color? Okay, Basically, when you write the numbers, right? When you write the numbers in Python, so like, when you write 10, so that is what it, it accepts. When you write 0 in the beginning, in Python, it does not take any number which starts with 0, okay? So it has no significance, right? That's why we don't start like, a normal number, we don't start with 0, okay? Shouldn't we use 0 in the start of the line in the code? Where? I don't know, what is this question? Okay, got it, okay, fine. So, see, now you have seen this simple code. There are a lot of differences. You will see those who are coded in Java, C, C++. You guys will see a lot of differences, but one very simple example we have taken. And in this, now you guys can tell me that what is, looks more cleaner and more better, like, easier, basically simple, I would say. Which code? Obviously Python, right? So, and anyone can understand. Let me know if someone have any doubt in this, and please don't tell me if you have any doubt in this and this. Do you have any doubt in this? No, right? Obviously not. But you will be having lots of questions in it. What is this hash include str.h? Why we are writing int main? Why we are writing int here? Why this is semicolon? What if I miss this semicolon? What if I miss this bracket? What if I not write this hash include str.h? Right? Then what is this return 0? Correct. What is this printf? Why not print? Why only printf? Right? Lot of questions will arise. Right? Similarly here, what is this class? What is this public? Well, what is this bracket? What is this string and then square bracket? Why we have given this? What if I don't write this? Lot of questions are going to arise. This is called the syntax of Java, which you have to follow. Java is a purely object-oriented programming language. So you have to create the class as an object for any task you are doing. Okay. Python is the functional language. So you have to create the functions and you have to write this thing in the beginning of any C code. If you want to use print and scan or printf and scanf, like, input output functions. This is the header file. In Python, you don't need that. First of all, you don't need any header file or any library to import in the beginning, at least to use some basic function. Those functions comes by default when you start your Python. Okay. Fine, everyone. So this is quite simple, right? So that's what we were discussing. That language should be simple, easy to understand, and expressive language. Then whatever language you select. And also you should remember one thing. Whatever Java can do, Python cannot do. And whatever Python can do, probably Java cannot do. All your tasks, for all your tasks, there is not a single language in this world which can perform all the tasks which you need, which can satisfy all your requirements. Not possible. We have database languages, we have front-end languages, we have back-end languages. There are different types of languages. Okay, so we don't have a single language which can satisfy all your needs. Okay, but yes, when it comes to the field of data science, Python is the most suitable language. Okay, compared to at least other programming languages. Okay, fine, guys. Any question till here?
No.
Okay. Great then. So, okay, guys. So let's start. So when we have seen the okay. One point I have missed. High-level programming languages. Okay. Few points will be coming related to this in this points. Okay. So first point is what? Low-level programming languages. The low-level programming language. Why we say low-level? Low-level because the language which a system can understand easily, right? Whereas high-level programming languages are those programming languages which a human can understand, okay? User can understand easily. These all are the high-level programming languages, okay? And these all are the low-level programming languages. So, as I said that your computer understands only 1 and 0 because computer is a set of hardware, so it understands only 1 and 0. So that is the low-level programming language. High-level programming languages, we are the user, we have used the words, right, which we can understand, and then actually these words are mapped to, like, you know, as we discussed that how it is going to convert it into the binary. So internally there are system or software which will do that, okay? So for doing that, we have the translators which will translate. So let's say two people want to communicate with each other in the different language. They are speaking different languages and they cannot understand each other's language, right? In that case, you need a translator. Similarly, in the programming languages or in the concept of in the field of computer science, when you code something into the high level, your system cannot understand, and you cannot understand low level, right? So you use the translator to translate that to the low level, and from low level to the high level, okay? So the first point between this, then why we don't code into the low level programming languages? Because if you will code into the low level programming languages, actually low level programming languages are architecture dependent, okay? For example, assembly code or low level code, machine language code. What processor you are using, how this processor is performing the different operations, the architecture of it, how the memory allocation is happening. These all things you should know. And when you will write the code, you will be writing the code specific to that set of hardwares or the components. It will be running only those set of component. If you will change any one of the component, it will probably not work. Let's say if you are using Intel processor, and for that you have written the code, and you replace Intel processor with the AMD processor, it will not work. That code will not work. If you will code into the low level programming language, okay? So low level programming languages are architecture dependent, okay? Whereas high level programming languages are not architecture dependent. You run this code, I have written this on Mac, I'll copy this code and I'll paste it into the chat box. You guys can also run this code on your own. Does not matter what operating system or what system you are using, what processor you are using. You just copy and paste this code and you run it. You'll be able to run this code. So it is not architecture dependent, okay? High-level programming languages are not architecture dependent. You should know about how this computer is working. Correct? You just write the code, and irrespective of the operating system and all, it will be running that. Okay. Fine. Now, if you do the coding into the low-level programming languages, as we have discussed, that it is a bit complex to code, to learn, to manage. Okay. See, mainframe languages like COBOL and all, right? Or different other programming languages, there are still some applications which are running on the assembly languages and all. And we have the requirement of the developers who know the assembly languages. We are using Python for developing most of the application nowadays. The new requirements are coming into Python, Java, right? Or in the other languages. So does it mean that we don't have the requirement of C, C++? No, we have the requirement, because there are a lot of applications which are developed in C, C++ and the other languages, right? And migration is not that easy. You cannot do that migration because the applications which are running, they are having the data, probably you might lose it. So you need the people who can manage that code. So still there is a requirement of the market. Requirement of the market is the C, C++, Java developers and all. Okay. Similarly, there is a requirement of those who know some low-level programming language. Not much, but yes, little bit we have. Okay. So it is very difficult to manage. Now, if you code into the low-level programming languages, it will be really difficult to manage those applications. Probably those are outdated. We don't have any applications which runs on the machine languages. But yes, those all are outdated. Anyway, so in case if you code some application, let's say if you develop Facebook, you'll be having probably, I don't know, like uncountable number of stream of zeros and ones. And if you, does not matter how much you're going to pay, but if you'll hire any developer who can manage that code, you'll not get it. No one is interested in it. Okay, so it is a bit complex to code into the low-level programming languages, whereas it is easier, okay, easier to code and learn and understand in high-level programming languages. Okay, fine. Point number 4. So if you are going to code into the low-level programming languages, as I said, you need to know the architecture. It means you are understanding, let's say if you code into the low-level programming language, so you are exposing the behavior of your system. Security concerns will be raised. How your system is behaving. If you will write some code, let's say if I'll write some code to add 2 numbers in low-level programming language, let's say machine language, first I have to know the architecture, and based on that I'll be writing the code. It means with the help of the code, you are exposing the behavior. Someone who is expert in machine language, they can easily get into your system. They know that how your operating system is behaving or how your computer is behaving. So it will raise the security concerns, and you also have to manage the memory manually. Okay. Whereas these things can be avoided in the high-level programming languages. Okay. So for example, did I do any memory allocation here? No. When I'll run this code, it will be like memory management and everything will be done automatically. Going forward, we have one class on memory management. Also, probably we'll discuss that tomorrow. We'll see that these all memory management part and security concerns are handled by the Python internally. You don't have to do anything. Some level of memory management you have to do in C also, memory allocation and deallocation. But it is not required in Python. Actually, C is called the mid-level language because it is the bridge between the low-level and the high-level programming language. That's the reason, you know, you still have some memory allocation and deallocation part left into the C++. But in Python, like it is truly high-level programming language where you don't have to bother about the memory allocation, deallocation, and the other security concerns. That will be automatically handled. You are not exposing. You have just written the code. Does anyone will be able to understand that how your computer is behaving, how the memory is allocated, how it is processing the data and all? No, right? Okay, and the most important part into this is that these low-level programming languages are neither portable nor platform independent. Whereas high-level programming languages are portable and may be platform independent. All like C. C is not platform independent, but it is portable. Java is portable and platform independent both. Python is portable and platform independent both. Okay. Fine. So portability means, let's say if you write this code here, and whether you can run this code, if I'll give this code, whether you can run it or not, right? In Java, you can do that. In C, you cannot do that. Sorry, in C, you can do that. This code you can run. But let's say there is a concept of some intermediate code, which can directly interact with your computers. So in case of Java, the intermediate code which will be generated, that can run on any system. But in case of C, it will not be running. So that is the concept of platform independent. We'll discuss about it. So as of now, you just understand one thing, that low-level programming languages are neither portable nor platform independent. About the intermediate code, we will discuss later. We'll understand that what is this intermediate code, concept of this intermediate code, and why it is generated. Whereas in the high-level programming languages like C, C++, they are portable, but they're not platform independent. Java, Python, they are portable and platform independent both. Okay, so you develop in one place and run it on many places. Like Facebook, is it system dependent? Is it hardware dependent? Is it operating system dependent? No. Does not matter where you want to run, you can run it anywhere, right? Okay, so these all are the few features and examples we have already seen into the machine language and the high-level programming languages, right? So these all are few points, difference between low level and high level. Now let's come to the points that we were discussing. Language should be simple, easy to understand, and expressive language. Okay. Point number 2. Whenever you are going to select a programming language, you should check whether that programming language.
Sir, I have an architecture-based question, so should I ask now?
Yes, please go ahead.
Yeah, so like in some of the articles, I was like seeing like people are saying that Python is more adapted to Intel processors, but not for like in AMD, especially the NumPy and the SkyPy packages are not so like well suitable. So is that correct? Like this kind of statement?
I don't think so. I have coded on both the processors.
Okay, thank you, sir.
It basically, see, when it comes to this point, it does not only include the writing the code. Okay, it comes about the processing speed and the the code which you are writing. So there are a lot of factors you need to consider when you are discussing about the processors. Okay. Okay. Anyway, so I think I had those points somewhere. This is what happens when you leave the teaching. I missed those points somewhere. Yes. Okay, so the second point is code should be manageable. We have already discussed this point. That what do you mean by managing the code, right? So when you write the code, see, it's not like you always write the code to develop the application. When you are writing the code, you should also think about the future part, that let's say if someone else is coming in your place, whether we should be able to manage. We can write this code in different ways, right? But when you are writing this code, like this is the simple code. Let's say if you are developing the application, probably they are going to be thousands or 10,000s or millions of lines of code. Whenever you are going to write a code, you should write in a way, or you should select a programming language. You can, as I said, you can code in the low-level programming languages also. You can code in Java also. You can code in Python also, right? But whenever you are selecting a programming language, you should think about that whether it should be manageable in the later stage or not. If it is not going to be the if it is going to be difficult to manage that code in a particular programming language, you should not select it. For example, developing this summation code itself in Python, it is manageable, but writing this code in assembly and the machine language, it's not manageable at all. So you should not select those kind of languages, right? So code should be manageable. The third point is performance. Very important point. Whenever you are going to select a programming language, you should think that you should consider that what is going to be the performance of the application. And some credit goes to the programming language also. For example, applications developed using C are more faster compared to the application developed using Python. Okay, C applications are faster compared to the Python or Java applications. Why? So if you see the translation, right? For example, let's say you have two people, A and B, they are communicating with each other. A knows A language, B knows B language, but they don't understand each other's language, right? So if you'll keep a translator which does the translation of both, who knows both A and B both, then probably the translation will be easier. But if you'll keep 2-3 translators in between them, for example, in between A and B, you put a person who is C, okay, who knows language A but does not know language B. He knows language D. So we'll put a person D who can understand C but cannot convert to D, right? So you'll put a person E who can understand the language of D and B also. So this translation will take a lot of time. This is what the performance issue in simple terms, right? Now, to pass on one message, you have to go through these different stages, right? Same thing happens in this C and Python also. In C, when you translate the language from high level to low level, there is one level of translation, just compiler. Compiles the code and it creates the executable code. And it runs on your system, gives the output. In Python, there are two types of translators. One is compiler and one is interpreter. Both you have. Performance obviously is going to, going to be down. It will take more time to run one application. Correct? So whenever, then it does not mean that, you should select C for doing the data analytics and the data science. Okay. Performance is one of the concern. For the data science applications, performance is not a big issue. And right now, in the current age or in the current situation, whatever you see, performance is not a big headache. The kind of systems you are having, the kind of high-end devices you are having, processors you are having, performance is not a big issue. We have i7, supercomputers, right? They can process the huge amount of data and the big codes probably in a blink of eyes. Okay, so performance nowadays is not an issue. Okay, performance can be handled, but the other things should be considered while writing the code. Okay. Next, we have discussed about the portability and platform independent. Okay. So we have already discussed that code should be portable and platform independent. Otherwise, just think about a situation where you have Facebook is developed, and for Mac operating system, you need a different Facebook. You need to run the different Facebook application. For Android, you need to run a different Facebook application. For different types of operating system, there are many operating systems we are using across the globe. And for each operating system and for each set of computer and set of manufacturers of the different components of the hardware, you need the different types of application, right? Different Facebook application, correct? That will be quite complex. So whatever application you are developing, that should be platform independent, that should be portable. Okay, if I'm writing this code should run anywhere. If it is then probably development time, you'll not think about the other problems. You just think about your focus will be on to develop the application. That's it. Rest all will be taken care of, right? So portability and platform independent is one more major concern. Okay. Now, next we have security features. So as we have discussed that, where the code the programming language which you are selecting, this should not expose the behavior of your system, right? So security features should be handled. So you should select a programming language where you as a user should not bother about the security features and the memory management. Like in Python, it can be handled automatically. Okay, if you select low-level programming languages, no, you have to do that. If you select C, you have to do that. Correct? So security is also a big concern. Then we have support for library and package. So we'll be coming to that. Before that, now let's start our discussion for the next topic, which is so you guys have understood that why we are learning high-level programming languages. These all are the few points. We will understand now why we are in the high-level languages, why we are learning Python. Okay. Before that, I need to discuss these points: source code, bytecode, machine code. What is these three types of code? And then we'll be coming to the concept of compilers and interpreters. Okay. Now, there are different types of code. Any question, guys, still here?
No.
No.
Let's come to the source code. What is the source code? The code which we write. Any code which you write, that is called the source code. For example,
how does Python run on our system?
This code is a source code. This is Python source code. This is C source code. This is Java source code. Whatever code you are writing, that is called the source code. Okay. Clear? Next, we have intermediate code. What is intermediate code? There are different types of intermediate code. One is executable code. One is object code. One is byte code. Okay. In the case of executable code, see, like, this is just the different names of the intermediate code. That's why I've told you intermediate code, not the byte code and all. There is byte code is also called the intermediate code, object code is also called the intermediate code, and executable code is also called the intermediate code. Okay, so this executable code, which is a type of intermediate code, is generated in case of C. The extension for that is .exe. .exe files are the executable code. So in case of C, the intermediate code which is generated, it is called the executable code, object code. In case of Java, the intermediate code which is generated, that is called the object code or the object file, byte code. In case of Python, the intermediate code which is generated, that is called the byte code, .pyc files. Okay, fine everyone. So every language generates some intermediate code, and that intermediate code has the different names. This object code can also be called the byte code, but no, you can't say the executable code. Byte code, similar. So you can say object code or byte code, but specifically when you talk about this Python, so we say that it is the byte code. In Java, we say the object code. Okay. So these all are the intermediate code which are getting generated in batch files also. Batch files also intermediate. Yes. Those all, see, different types of files are getting created. Batch files are also getting created. They are also the kind of intermediate code, but that is used for a different purpose. Okay. Fine. Okay, intermediate code, and then finally we have machine code. Machine code, we have discussed the code which is written in terms of zeros and ones. Okay. Now this code which are generated here, zeros and ones, they are the last stage. Before, like your instructions which are written into the source code, eventually that has to be converted to the machine code. So it will be going through this process, first into the intermediate code based on the language, and then it will be converted to the machine code. These machine code instructions will be given to your processor, and then processor will start executing those machine code instructions. Okay, fine everyone. So these all are the different types of codes we are having. So next we are going to understand how a Python program runs on our system. This is very important. Okay, so a lot of things you will feel that it is not important why we are discussing that, but believe me, these all are important. You will understand it later when you will be start writing the code, at least for those who are coming from non-programming background. Okay, so let's start the discussion on this. Everything that we are discussing has a relation in the further classes. Okay. Is it boring?
No, not so far.
No, not at all.
No, sir.
No, sir.
Not
Great.
It's actually quite interesting.
Definitely, I agree.
Only thing I'm wondering is what is the tool you are using to put this, because we are not seeing any toolbar on top, only the plain sheet.
Which tool? Where?
Right now you're using, right, like the paint or something.
This is whiteboard of
Whiteboard.
Yeah, this is in Zoom itself.
Okay, okay.
So this is whiteboard.
Whiteboard. Okay, thank you.
Source code we have, then this is called the intermediate code, which is nothing but the byte code. Okay, and this final one is the, I'll be writing the output. Okay. Interpreter. Okay, so first of all, we have discussed about the source code. So now you guys know about the source code, right? What is source code? Let's say I'm going to write the code. A is equal to 10, B is equal to 20, C is equal to A plus B, and print C. Okay, this is the code we have written. So you will find that what is this compiler and interpreter then? So this bytecode, as we have discussed, this is a kind of intermediate code. When this source code will be compiled, this intermediate code will be generated. So this is the structure of the execution sequence of the Python code. Starting from when you write the code to get the output. Actually, when you code it, you just see these two stages. Okay, the first one and the second one. Rest all are abstract. You as a user will not be able to see, but actually internally it happens, and I'll prove it, it happens. We'll see that. Okay, we'll see at the different stages how the bytecode is getting generated. Interpretation, okay, compilation. These all things we'll see. Okay, and I'll give you a few points. Based on that, you can verify, yes, it happens. Okay, so now, but like, let's say if you will see this particular code, when I have written this code to add two numbers, so I have, this is the source code, and when I'm executing it, I'm getting the output, right? I didn't see the intermediate steps. This is what the abstraction in Python. No, sorry, not abstraction, not the object-oriented programming while abstraction. Okay, it is a different means. Those all intermediate steps are not in front of you. Those all are behind the screen. It happened. Okay, just when you ran this code, it happened. Okay, bytecode got created, it got converted to the machine code, interpretation happened, compilation happened. Okay, all these things happened. Okay, so this is the sequence. Now, if you look at this example or this diagram, so what you will see that, see, if you are coming from C or if you're coming from Java, you might have seen the compiler and JIT compiler in Java, or in C, you might have just seen one compiler. In Python, you have compiler and interpreter both. What is this compiler and interpreter? So let's just have a quick revision on the compiler and interpreter. Now we are going to discuss about the translator. There are mainly two types of translators. Okay, translators. Okay, why do we need the translators? Just now we have discussed that if two people want to interact with each other, you need the translators, right? If they don't know the language of each other, you need a translator between them, so that they can that translator can translate A to B, B to A, whatever. Okay. Similarly, in the case of computers, we are user. We understand only high-level programming language. We can understand this. Can we understand this? No, not at all. So what we are doing, what we are going to do, we need a translator, and there are two types of translator which does the task for us, which is compiler, and the second one is the interpreter. Okay, compiler and interpreter both are translators. What compiler does? Compiler compiles the code, interpreter interprets the code. So what is the difference between these two? What is the, like, why do we need two translators here? Okay, first question. And how this compiler works, how this interpreter works. Okay, so let's come to this. See, what compiler does is, let's say if you have a code, any code, it can be any code. Okay, you have a code, okay, and you have a compiler over here. What compiler is going to do, always remember that this compiler will take this code as input, okay, and it will generate some intermediate code always. It means compiler always generates the intermediate code, right? Okay, first point. Second point, let's say if you have written some lines of code over here, you have written some lines of code. What this compiler will do, it will take this whole code at once and compiles it and generates the intermediate code. Okay, clear? Point number one, that compiler always generates the intermediate code after compilation. Point number 2, compiler takes the whole code at once and then compiles and generates the intermediate code. Point number 3, let's say if there is some error into this code, which is compiler is going to check, then it will not compile that code. Okay, it will not generate the intermediate code at all. Okay, for example, there are two people who are talking to each other. The first person saying whatever he wants to say, and there is a translator in between them. So if first person says some bad words, is the translator going to do that? No, he will stop it. He'll ask him not to do that. Okay. Similarly, this compiler, if there is something which is wrong into this code, compiler will not create the intermediate code. Compilation will not take place at all. So these all are the 3 points that you need to remember in the case of compiler. Number 1, intermediate code will always be generated. Okay. Point number 2, compiler takes the whole code at once and then generates and then compile it and generates the intermediate code, right? And point number 3, if there is any error in code before compilation, then compilation will not happen and intermediate code will not be generated. Okay, so these all are the 3 points that you need to remember in the case of compilation. Okay, any question, guys?
Yeah, I have one doubt. So compiler, it checks for syntax also, is it?
Yes. It
That's
depends. See, the compiler and interpreter are the programs. Okay, these all are softwares basically. And you can decide that what your compiler needs to check. Okay. In case of Python, it checks the syntax actually.
Okay.
So like if you will see Java or C, in case of C and Java, not only syntax, it checks lot many things. Okay, it does so many things. So that's why, see, based on that only, based on the task your compiler is doing, you can decide whether a language is compiled language or interpreted language. I'll discuss that point in a few minutes. Okay. Python is having compiler and interpreter both, right? But we say Python is interpreted language. Why? Everywhere on the internet, everywhere you will find Python is an interpreted language. Why? You don't say it is a compiled language. So it depends on the task in your hand, what task your compiler or interpreter performs. Okay, we'll be coming to that. This is not required. Okay. So now interpreter, again, we have some code. See, I'm talking about in general. I'm not talking about the source code and intermediate code. Don't link this particular slide with this slide. Okay. In general, how compiler and interpreter is working and what is the idea behind that. Okay. In general. Now, whenever you are going to, like, what interpreter does is, so interpreter interprets the code. It is not, first of all, it does not generate any intermediate code. Point number 1, it directly gives you the output. Point number 2, it will take one line of code or one instruction at a time and then gives you the output. Okay. Then it will take the second instruction, executes it, and then gives you the output. Third instruction executes it and then gives you the output. And so on. Right? So intermediate code will never be generated in the case of interpreter because it is directly executing each instruction and giving you the output. And point number 3, if there is any error in your code, the code which interpreter is working on, it will stop the execution then and there. Okay. If there, let's say error was at this line, so previous 3 lines will be executed. It will be giving you the output for these 3 lines, but after this 4th lines, it will never be executed. Like it will not be executed. So you have to rectify this line to execute. Though these lines are correct, these rest of the lines are correct, but it will not execute them. As soon as it finds the error, it will stop it here. Clear? Difference between compiler and interpreter?
Sir, can you just repeat it if you don't mind? I didn't get it.
Right. So what interpreter does, so what we have seen in the compiler, it generates the intermediate code always, whereas in the case of interpreter, it never generates the intermediate code. Point number 1. Point number 2, compiler takes the whole code at once and then generate the intermediate code for whole code at once, right? Whereas interpreter takes 1 line of code or 1 instruction at a time and execute it. Why I'm saying instruction, you will understand it later, but write this somewhere. Instruction, I have discussed about the instruction, write it somewhere, okay? So you can think of it as a line. 1 single line of code it will take once and then it will execute it. Then it will take 2nd line of code and then it will execute it. Then it will take 3rd line of code and then it will execute it, right?
Right.
Fine. So it will not generate the intermediate code, it will directly give you the output. Point number 3, if there is any error in the code, it will not generate the intermediate code at all. It will not compile the code at all. Even for these lines also, it will not compile the code. Though these all are correct, but it will not compile the code. Whereas interpreter, if there is some error at this particular line, it will execute the previous lines, but further lines will not be executed until unless you remove that error.
Okay. Understood. Thank you.
Okay, so what we have, intermediate code will not be generated. Okay, interpreter takes 1 code at a time, 1 line of code at once, and then interpret it and gives the output. Okay. If there is any error in code before interpretation, then it stops the execution immediately. And code before that error will be executed, right? Clear? So this is about the interpreter. I hope this part is clear. Any question?
Abhishek sir, I have a question.
Yes.
Okay, so if you say any error, then will it include even the logical errors, or is it just syntactical error?
No, mainly the syntactical error and runtime error. So compile time errors are also of different types, 3 types. One is compile time error, one is runtime error, and one is the logical error. Your compiler and interpreter will never check the logical error in your code. Okay. Fine. Logical error, you as a user has to make the logic correct. Okay. Whereas syntax error or compile time error, runtime error will be checked by your compiler and interpreter.
Could you just go back to that page for 1 minute?
Sorry?
Could you go back to the previous page where you wrote about the interpreter and compiler? Yeah, just 1 second.
Okay, guys.
Thank you.
Okay. So now we have discussed about, so I hope you guys have understood concept of compiler and interpreter, right?
I hope this video helped you understand why we need both a compiler and interpreter.
Now, so the next question is, why do we need compiler and interpreter both? If you will take the example of C, if you will take the example of Java, you will see that you have the compiler. And moreover, like, you know, Python is, we say Python is an interpreted language. Why we say Python is an interpreted language? Why can't we say Python is a compiled and interpreted language? Actually, Python is compiled and interpreted language. But generally, as I said, that based on the task, which compiler interpreter performs, we say it is compiler interpreted. So what I'm trying to say here is, let's say you have the C code, okay? C code, and you have the compiler over here. And it generates the executable file. So we have abc.exe file, which is the executable file, and we have the C file, which is abc.c. Okay. So what happens in the case of C, it takes this code and generates the executable code. If you have seen the code written in C in this case, this is the sample C code, right? I'll take just this part, just this 3 lines of code. Okay? And I'm writing it here. So this is the code we have written in C, right? So now, if you see here A, B, and sum, what this compiler does, if you'll not write int before this, will it work? No. Why? Because compiler need to understand that what kind of variable it is, what kind of data you are going to store in it. If you're not going to mention that what kind of data it is going to store in it, it will give you the error. Why? Because compiler is designed in such a way that when it will check that, okay, A is integer type, it means it will do the memory allocation. So there is a concept of memory allocation and type checking. We are discussing about that. Based on this, we will say that whether the programming language is the compiler and interpreter. Okay. So if this task is done by the compiler in any language, you can say it is compiled language. And if this task is done by the interpreter, we can say it is the interpreted language. In case of Python, interpreter does this task. In case of compiled languages, compiler does this task for you. So what this compiler does, it checks if it is integer, what it will do, it will take a memory location in the RAM, okay, and it will give a name to it A, and it will say that it is going to be integer type only, okay. It is going to be integer type only. So it will specify that it is int type. Okay. It means only integer data can be stored. You cannot store any other data. Okay. So compiler does this task here. It checked int, and based on that, it did this. It checked the type, and then allocation, memory allocation happened while compiling the code itself, right? Clear, everyone?
Yes, sir. Thanks.
Okay. Now, in case of, so this was it. This was the case of C. Similar is the case of Java also, but in Python, what happens when you write the code? Have I written that what kind of data type it is? No, right? No. Not written the data type. So how this code, like how it is going to understand? So if you will write this code here, let's say, so let's say if you'll write this code here, A is equal to 10 and print type of A. It is going to give you that it belongs to class int. Okay. Why it belongs to class int? How it identified that it is integer class or integer object. So this is the task of your interpreter. What compiler does is it just checks the syntax, compile. So now let's discuss about the type of errors. Okay. Type of errors. So there are mainly two types of error. One is compile time error, and the second one is the runtime error. Okay. In the compile time error, we have syntax error in Python and indentation error. Okay. In runtime error, we have name error, we have value error, we have type error, etc. There are many type of other error. Okay. So this compile time error, this will be checked by the compiler only, and these runtime error are checked by the interpreter only. Okay. In Python I'm discussing. Okay, type of errors in Python. Okay. Actually, in all languages you have these two types of error, but in Python this compiler checks the compile time error. So syntax error and indentation error, runtime error just check this runtime error. It will be checked by the interpreter. So what is this syntax error and what is this indentation error? So if you will look at the code, let's say syntax, as I said that whenever you write a programming language, right? Whenever you select a programming language, every language has some syntax and specific set of keywords. So if I'm writing this code, A is equal to 10, B is equal to 20, C is equal to A plus B and print C. This is the simple code. What is the syntax in this? The syntax is, let's say when you are going to write this assignment operation, values should always be written on the right hand side and variables should always be on the left hand side of the equal to operator. If you will change it, it is going to give you the syntax error. Okay. Clear?
Yes.
20 equal to B.
Yes.
So this is the syntax error. Okay. Now, again, the rule is that if you are using print function, this is also syntax. If you are using print function, you have to put the open and close parenthesis. If you miss any one of them, it will give you the syntax error. There are many other syntaxes. Like, you know, every class you will learn a new syntax. Okay, so it is not possible to discuss all the syntaxes here, but you understood the syntax error, right? The rule of the programming language. If you're not going to follow that rule, it is going to give you the error. You have to follow the rules, right? That comes under the syntax error. Next is indentation error. Okay, what is indentation error? So indentation is having a special importance in Python. Indentation is basically the space. Using indentation, you create the block in Python. Giving unnecessary indentation in Python code will raise the indentation error. This is also caught by the compile time error. Indentation error. And why I'm saying this is the compile time error? How I can identify this is the compile time error? How can I identify? How can I tell that it is a indentation error or compile time error? Indentation error is a compile time error, or syntax error is a compile time error. So if we say Python is only interpreted language, it means if I will make some mistake here, then at least this code should be executed and it should give me the output for print C. Why it is not giving me the output for print C?
Because it's an interpreter. It's Python is an interpreter language. So there's one.
Sorry?
It's an interpreted language. So if there's like one mistake, the whole
if
code
it is no, see,
Compilation error.
Compilation error. Python is an interpreted language. If it is only interpreted language, then at least this output should be given, right?
Correct.
Right. At least print C, because it is line by line execution. Compiler. There is the role of compiler also in Python. So first compilation is happening, right? In the example, in the diagram, we saw first compilation is happening. So compiler found this error that the syntax is missing. So it didn't compile the code. Bytecode not generated. If bytecode is not generated, intermediate code interpreter, what interpreter will do? You saw this image right here. This compiler is coming first. If bytecode is not generated, what interpreter will do? It will do nothing, right? So it is not giving you the output at all, even for those first four lines also, because the error over here is the compile time error. Since it is compile time error, so bytecode didn't get created.
Then why do we need interpreter? Either way, the intermediate code is already checked. All the syntax errors and everything is checked. So why do we need interpreter?
It is fine that you check the syntax or indentation error here with the compiler. But as I said, that memory allocation also has to be done, right?
Right.
Right. And then See, like if you will see the example of C, these all things are done by the compiler itself. But the problem here in C, we discussed the problem. What was that problem? That Python is not platform independent. C does all that task here, compilation, all those tasks it will do, memory allocation, type checking, all these things will be done at the compilation stage in case of C. But C is not platform independent. Okay, whereas Python is platform independent. Okay. Clear, everyone? Any question? We'll discuss about this. We'll discuss about this. Why we need, what this interpreter is doing here. Actually, there is a concept of PVM. More specifically, I should say that there is a PVM here. Okay, Python virtual machine. Because of this PVM has the interpreter. Because of this, your Python becomes the platform independent. Your C is not platform independent. It just has the compiler, it can do all the tasks. But here we have divided that task into two parts. Now this bytecode can run on any platform. If you have the PVM installed, you can run it on any platform, whether Mac, whether Linux, whether Windows, anything. Okay, because of this PVM.
So interpreter makes it platform independent.
Not interpreter, you should say, yeah, interpreter and PVM, not interpreter. Only interpreter will not make it platform independent. This whole package of PVM, interpreter is a part of the PVM. Okay. Interpreter is just the feature of this Python which executes the code line by line, and does the memory allocation type checking for you. Okay.
So this PVM includes the compiler also, right?
No, PVM does have the interpreter, and there is IPython, which has the GIT compiler. So this PVM, in the case of IPython, will be having the GIT compiler. So as of now, you understand one thing: PVM is a virtual machine, just like your operating system. And the operating system run all the application. PVM can run only Python applications. Okay.
Yes.
Okay. Okay. I'll stop this discussion here. We'll start from here by tomorrow, and then we will continue. Any question you guys have till here?
It was a really nice session, sir. Thank you.
Thank you, Avinash. Any question, guys? Shashank, do you have any question?
No, sir. Thank you. It was a really good explanation so far.
Okay, then.
Just wanted to discuss maybe tomorrow on this part when you said this splitting of up into compiler and interpreter makes Python architecture independent. So just wanted
platform
to
independent.
Yeah, sorry, platform independent.
Yes, we will. I will prove
how
that.
Yeah,
I'll not discuss, but I'll prove that.
Okay, thank you.
I'll prove that. I'll show it to you.
Also, for today's class, are there notes anywhere on the LMS portal?
Sorry, I didn't get it.
For today's class, when we spoke about all the different concepts, are there notes documented anywhere in the LMS portal?
Yes. We have the notes. 1 minute, I'll show you. This is the notes which I have created. You can see this.
No.
Your screen is not sharing. Yeah.
Can you see this?
Oh yeah. Okay.
This is the notes which I've created, and from this only I teach. Okay, these all are my notes basically. If you'll read this, tomorrow's class also is going to be from here itself. Okay. This one we have discussed, right?
Right. Okay.
Read all these things, and the important part is this links. Okay. Okay, guys. So it is available into your Google Drive. Actually, you go to, what is the Google Drive link here? 1 minute. Let me upload this file as well. It is 21st Feb, right? Learnbay.
Can we find this drive in the LMS portal?
Yes, it is there. Feb. This is 20th Feb or 21st Feb batch?
21st Feb.
21st Feb.
Oh, this is 21/02/2021. So this is your folder, right? This is the Learnbay content folder. In this you have Python, and you have this notes, Python introduction that we discussed today. Okay. And my class is going to upload here.
Cool. Thanks, Abhishek.
Thank you, guys. Bye, everyone.
Thank you.
Thank you. Thank you.
Thank you. Bye bye.
Great day ahead.
Thank you.
Hey learner, hope you enjoyed this session. Stay tuned for the 2&D part of this project.